The next question is about labor planning. And this question is chosen from, again, the T3 file available in your chapter 3 course content. So there is a bank. It has both full-time and part-time employees. Based on some limitations and rules, it is willing to minimize the personnel costs. So the goal is to find the best schedule of employees by assigning their shifts in a way that the personnel costs are minimized. As you can see, we have the number of employees required in each period. This is one of those limitations that I was talking about. And what we will do is we split the full-times into two groups. So I have two types of employees, the full-times and the part-times. Half of the full-timers eat at 11 and the other half, they eat at noon. So each of them has 1 hour lunchtime and they're not available in that period. The part-time employees, they must put in exactly 4 hours per day, but can start anytime between 9 to 1. So the second group are part-time. They work 4 hours per day and they can start from 9 and maximum they can start their work at 1. Based on these information, my decision variables of the number of full-time employees and the number of part-time employees divided in 5 groups. The number of employees, part-time employees starting at 9, the number of employees starting at 10, at 11, 12, and 1. What we will do is to split the full-timers into 2 groups with the same number of employees equal to half of them. The first group is not available from 11 to 12, and the second group is not available from 12 to 13. Also, the part-timers will be categorized in 5 groups based on their availability, well, which are shown from P1 to P5 in the table. For example, P1 can only work from 9 to 13 because they start at 9 and they can only work 4 hours. You can see different time periods here in the table on the left-hand side. We have time period 9 to 10, 10 to 11, and so on. And the first group of the full-timers are unavailable from 11 to 12. We will use cross signs, as you can see, to show whether we have access to a particular group at that period or not. And we will follow the same logic until we get the full table marked with these cross signs. And now this table will help us to develop our model. In the objective function, as you can see, we are willing to minimize the cost of the system. $160 for each full-time employees plus $42 for each of the part-timers. Now we should focus on the constraints. Between 9 to 10, as you can see, only full-timers and the group 1 of the part-timers can work. The summation of these 3 groups should at least be equal to 10. I cannot assign less than this number. It can exceed 10, but accepting more costs, but according to the policies, we cannot go under this value. And the other constraints are very similar to this. For example, let's go with another constraint here. Between 12 to 1, only half of the full-timers are available. So half of F plus the summation of the 4 part-time groups as P1, P2, P3, P4 should be greater than or equal to 16, which is the required number for that period of time. There is another limitation available in the problem, and according to the corporate policy, this policy limits the part-time hours to a maximum of 50% of the day's total requirement. So let's take a look at this. How many hours part-timers can work? It is shown in the left-hand side of this constraint. And what is the half of a daily total requirement? That is shown in the right-hand side of this constraint. And also, the number of full-timers should not exceed 12, and F and PIs, my decision variables, should be non-negative.